Let's take a look at more probability. This time we're going to look at conditional probability. A conditional probability contains a condition that may limit the sample space for an event. You write a conditional probability by saying the probability of event B given that event A. So again, similar to just looking at one event, now we're looking at one event conditional on another event. Probability of event B given event A has already happened. Let's look at an example. Here I've created a hypothetical table after asking the question, did you do a household chore last night? Of the males that I asked, 15 total, 7 did chores and 8 did not. Again, that's 15 total males. Of the females I asked, 13 total females, 7 did chores, 6 did not. Let's take a look at the probability of an event based on another event. So, let's do the probability of somebody who did a chore if the student was male. So when we write this, we're looking at first whether or not somebody did a chore. We know that 7 did a chore if they're male and 7 did a chore if they're female. But it only matters in our case if they're male. So male must happen first. We must take a look at the males. How many total males are there? There are 15. How many of them did chores? 7. So our probability is 7 over 15. An easy way to look at that is you might write a fraction, 7 / 15. If we look at chore versus the total males, that might help us remember which way to write the fraction. This time, let's look at females if they did chores. So, a female if they did a chore. So how many people did the chore, since that's what we have to look at first? 7 + 7, 14 did the chore. Of those 14 who did the chores, how many of them were female? 7. Conditional probability takes a look at the event we want out of just the situation we want, not the total. Let's take a look at another example. Let's take a look at this table. This is municipal waste collected in the U.S. in millions of tons. Americans recycle more and more material through municipal waste collection each year. Use the information in the table, based on the recent year, to find the probability that a sample of recycled waste was paper. So here's what we want to do. We want to know what the probability was of what was recycled was paper. So here's how we write that. The probability of paper being recycled equals what? So to figure that out, what we need to do is we need to know the paper, 34.9, and out of how much was recycled. That means we need to add up all of the recycled numbers. 34.9, 6.5, 2.9, 1.1, and 15.3. All of these numbers came from my recycled column. I don't need to worry about the not recycled because my probability is conditional. It's conditional on whether or not it was recycled. Now when solving these, we will add up all these numbers at the bottom so we can get a total, and then we will take 34.9 and divide it by that. Check your work. You should get approximately 0.57, which is the same as 57%. Let's take a look using the same table at another situation. What's the probability that metal and glass were not recycled? So let's take a look at our not recycled. Again, metal and glass together, so we'll take 10.1 plus 9.1, because that is what we want to happen, 10.1 and 9.1, metal and glass, over the parts that were not recycled. 48.9 plus 10.1 plus 9.1 plus 20.4 plus 67.8. Remember, add the top up, add the bottom up. When adding the top and the bottom numbers, the top, I got 19.2, and the bottom, 156.3. When dividing those out, I get 0.1228, and so on, which is 12.3%.